Good day, students. Today, as you can see on the board, we are going to talk about ionic bonding. Ionic bonding. Of course, you know right now that we have lots of elements, at least about 118 of them as at now have been discovered in our universe. And you know, all these elements are arranged in a table known as the periodic table. We've just talked about this, known as a periodic table. Now, these elements, some of them are metals and some are non-metals, as we have seen before. Now, the elements, as I told you earlier in periodic table, in all the groups of the periodic table are unsatisfied with their outermost shell. They are not happy with their outermost shell. They are not satisfied. They are not contented. They need to fill the outermost shell. They need the outermost shell to be full. There are certain numbers of electrons that will fill the outermost shell, and they desire this. They want this. They love to have this. Then what do? You see, we have a group we call group 0. Of course, you know this is group 1. This is your group 2, group 3, 4, 5, 6, 7, and group 0. These group 0, they are the only elements. The elements in this group are the only elements that are satisfied, as you know earlier from the periodic table. This group, they are happy with their outermost, the number of electrons in their outermost shell, because their outer shells are filled. They are full outer shells, so they are happy. They are happy. Others want to be like them. Others want to be like them. And you remember, we have on this side, we have on the right side we have non-metals, and on the left side we have metals. On the right side we have non-metals, and on the left side we have metals of this step. Now, metals have few electrons in their outermost shell. We are going to consider only group 1, group 2, group 3. You remember from the periodic table, group 1 elements have 1 electron in their outermost shell. Group 2 elements have 2 electrons in their outermost shell. Group 3, and so on and so forth. Now, the metals are in group 1, 2, and 3 here in the periodic table, except this. As far as you are below this, you are on the left side of this magic line, this staircase, then you are a metal if you are on the left side. So all these metals, they are not satisfied with the number of electrons they have in their outermost shell. Even the non-metals are not satisfied except this group, because their outermost shell is full. So what do? What happens? The metals, because they have few electrons in their outermost shell, they want to do away with these electrons so that the next shell, you have done electronic configuration, you know the next shell will be full. Then they will be satisfied. They use something to get something, so then they will be satisfied. So they use the outermost electron to get full outer shell. The next shell will now be full. They are satisfied. They are happy. They are content with this. And the non-metals, they have many electrons in their outermost shell. Take for example, group 7. They have 7 electrons in their outermost shell. Come on, you do not expect them to lose 7 electrons. They just need 1. So, instead of losing the entire 7, they feel it is better for us to look for 1 anywhere it is, so that we can just be like these guys who are full outer shells. Instead of us to lose 7, let's look for 1 anywhere it may be. That's what group 7 is saying. Group 6 is saying we need 2 more to be like these guys. 2 electrons more. Let's look for 2 instead of losing the 6. This is what is happening. We are going to look at these groups. And I told you ionic bond. And I told you bonding generally. Bonding generally, when you say bonding, chemical bonding. Because these elements, atoms of these elements, want to attain the noble gas stage, the group 0 outer electron shell. They want to have it. They want to look like those guys. So chemical bonding must occur. Chemical bonding must occur. The chemical bonding which brings about this, which lifts them, which takes them to that prestigious level, which takes them to that noble gas outer electron, the noble gas electronic configuration, to fill their octet. When you say octet, 8 or duplet 2. There are 2 types of bondings that will do this for them. It's either they undergo ionic bonding or covalent bonding. If they undergo ionic bonding, at the end of this bonding, they will now have full outer shell. If they undergo covalent bonding, at the end of the bonding, they will now have full outer shell. So, these 2 bonding takes them to where they are going. That is why we are going to discuss these bonds, these bondings. Ionic bonding and covalent bonding. So the bonding, there are more bondings, but the bondings which takes them to where they are going, ionic bonding and covalent bonding. How does it occur? Ionic bonding and covalent bonding. How does it occur? How do they occur? Let's look at ionic bonding first. I've written here before. Take for example Mr. Sodium. It's in this group, Na. Mr. Sodium has atomic number of 11. So 11 electrons, 11 protons, therefore 11 electrons. So the electronic configuration, as you know, is 281. Mr. Chlorine is in group 7. When you look at the periodic table, it's in group 7. So it has atomic number of 17. So it has an electronic configuration of 2,8,8,7. Chlorine is looking for 1 to complete its octet, 8. And sodium needs to lose this 1 to complete its outer octet, 8. When sodium now has 2 8, it now looks like who? Like neon. It is not chemically like neon. It is not physically like neon. It only has a similar electronic configuration as neon. Neon is 2 8. So when sodium loses its 1, it becomes 2 8. Sodium prefers to do that. Lose something to gain something. So it becomes like neon. So it's happy. Chlorine, we prefer to gain 1 from wherever it can get it from, to be like argon, because argon has 288, and if chlorine 288, and if chlorine gains 1, it will now have 288 like argon. That's what it wants to achieve. How does it get this? Now, is what we call dot and cross diagram. This is what I'm going to draw now. Before I draw it, let me just duplicate it so I can get something for that man there. Now sodium has 2H1. That means 2 in the outermost shell. In the innermost shell, I'm going to use dot for sodium. You know this before. This is not what you don't know. Eight and 1. 281. And chlorine has 2887. I'm going to use cross for this. That's why we call it dot and cross diagram. So you can see so chlorine has in its outermost shell 7. Then what happens? Mr. Chlorine is here. It's a non-metal. And Mr. Sodium is here. It's a metal. Okay. It's just like a young man and a young woman. A young man is a boy. A young woman is a girl. The man wants something from the girl, and the girl wants something from the man. What happens? The family of the man will say, the family of the woman will say, you girl, you boy, bring something to marry our girl. It's just like a marriage. Bring something to marry our girl. When you marry our girl, you become a man, and our girl becomes a woman. This is it, like a marriage. Okay, this is the metal. So the ionic bonding is a bonding between metal and non-metal. Ionic bonding is between metal and non-metal. Metal plus non-metal. Y covalent bonding is between two non-metals. Non-metal plus non-metal. Ionic bonding is between metal and non-metal. Y covalent bonding is between non-metal and another non-metal. So now we continue with our ionic bonding. That is a girl, that's a boy. The non-metal is a woman, this metal is a man. So the man, which is the metal, is about to marry the woman, which is the non-metal. So in so many traditions in the world, if you want to marry a woman, you need to bring something, give the woman something. And many religions too, especially the Islamic religion. You need to, the man needs to give something to the woman. Whatever the woman needs, she has the man. This is exactly what is taking place here. Chlorine is the woman needs 1 electron. And of course, sodium is so happy because it has that electron. Of course, it was looking for what to do with it before. Now, it has a way to do away with it. So, for the marriage to take place, this is what you call, in the Islamic world, mahram. And in the Africa, they call it dowry. So, in so many cultures, you call it so many things. So, this electron will move from sodium and it will go to chlorine. This electron from sodium, which is the electron is disturbing sodium. Sodium was looking for something to do with it, so that it becomes, it has the electronic configuration of neon, a noble gas. So it will be self-sufficient. Now, in this marriage, it will get that. And chlorine was looking for an electron desperately to be like argon, a noble gas. Not that it will chemically be like argon or physically be like argon, but it will have the electronic configuration of argon. So it is getting that electron from this guy is to marry. Please, in your exam, sodium is not marrying chlorine. We're just using this as analogy. So sodium loses its outermost electron and gives that electron to chlorine. Sodium loses its outermost electron and gives that electron to chlorine. In your exam, you cannot move the electrons like this the way I'm moving the electron. So what do? You simply draw an arrow. You simply draw an arrow like that. So that electron is moving that way. After the electron has moved that way, after the electron has moved that way, this is what we now see. Remember, the electron coming here. This is now we now see electron flies there. Initially, this was 281, this was 287, and now this is what we see. This now will now become 28, just like neon, and this one becomes 288, just like argon. But it does not just end there. When a boy marries a girl, he becomes a man because he has paid the dues. He paid the dues. He paid the dues. He transferred the electron to the chlorine, so he becomes a man. And the chlorine atom, having accepted the electron, agreed to accept the electron, so the chlorine has become a woman. Being a man, sodium will become positively charged. Sodium atom becomes positively charged. Being a man, sodium atom now becomes positively charged. And being a woman now, because it has excess electron now, one excess, so it becomes negatively charged. So this guy becomes positively charged. Sodium, we call it sodium ion now. It's no longer Na, it becomes Na plus. This guy is no longer Cl, it becomes Cl minus. So in case they ask you to write the electronic configuration of Cl minus, it is 288 because it has gained an extra electron. And sodium has lost its outermost electron, it becomes 28. So the outer electron again is empty. You don't need it again. You may remove it. It doesn't matter. You may leave it there. It doesn't matter. We don't need it. This is now our outer electron. And this outer electron is now full. So what do we do from here? The two of them, because this is positive and this is negative, and you know from law of electrostatic, in life, everything that are opposite, they always try to attract themselves, just like the man was attracted to the woman. So positively charged sodium Because when an atom loses electron, it becomes positively charged. When an atom gains electron, it becomes negatively charged. Chlorine has gained electron, it has become negatively charged, and it is now called chloride ion. And sodium has lost electron, it is now called sodium ion. So, because they are opposite charges, they attract each other, and they do not just attract each other like that, they stay together forever and ever. They stay together forever and ever. So sodium and chlorine stay together forever and ever. They stay together because this is negative, this is positive. They attract each other and they stay like that forever and ever. So look at it. Sodium ion, it has its complete outer shell, so it's like the noble gases. Chloride ion, it has its complete outer shell, it's like the noble gases. So they stay like this forever and ever. I may not draw this. Again, that shell is gone, no problem. If you draw it, if you don't draw it, it doesn't really matter. So this is 2,8 and that is 2,8,8. So this is ionic bonding. Sodium is satisfied, it's called sodium ion. Chlorine atom becomes satisfied, it is called chloride ion. So the two of them will now stay together forever and ever. In a union known as sodium chloride. Sodium ion stays with chloride ion to form a union known as sodium chloride. Sodium chloride. This is ionic bonding. This is the simplest one we can get. Let us now look at others. What if, so I don't waste my time. So you have written this. If you have not written it now, go back and write everything. So we want to look at the ionic bonding between magnesium and between magnesium and sodium and oxygen, between magnesium and oxygen, and let's say chlorine, between magnesium and chlorine. Mg as 12, so it is 2H2, and Cl as 17, it is 2H7. It is looking for 1. It is looking for a place to throw this to, so it becomes like a noble gas. So 2. H2 and 2H7. In so many exams, they tell you to write the outer, to draw the outer electrons only. In many exams, they tell you to draw the outer electrons only. Now, what happens here? If magnesium loses, because we said metals lose to become positively charged. If magnesium loses this one and gives it to this chlorine, yes, chlorine will be satisfied because it will have 8 in its outermost shell. It is satisfied. It is now like argon. But magnesium is not still like neon, the closest noble gas. Magnesium is not still like that. So it needs to lose one more to be like that. So it requires another chlorine atom. So magnesium needs to give its outermost electron, because there are 2 to 2 chlorine atoms. Because when it cannot give 2 to 1 chlorine. It will be too much for the outermost electron of chlorine. So it gives what? It gives the 2, but it needs to give the 2 to what? To 2 different chlorine atoms. To 2 different chlorine atoms. It needs to do that for 2 different chlorine atoms. I'm going to clean this now. Now, so this is another chlorine. So magnesium will give this to this chlorine, and it will give this to this chlorine. This chlorine will be happy because it has full outer shell, and this chlorine will be happy because it has 2 outer shell, full outer shell. And magnesium will be happy because it has full outer shell, and this one is no longer important. It is empty. So this is the new outer shell of magnesium. So how do you draw this in an exam? Because you cannot move the electrons the way I'm moving the electrons now. So how do you draw this in an exam? You simply draw this and draw this. So 2 electrons that way. This is what you will draw. But let's draw what it will become after this has happened. So let's see what it will become after this has happened. So this is what you are going to see. So this one moves there, and this one moves there. And what are you going to see? You now see this will now become the next step. Now that's the first step. The next step now we now have our you are going to draw in an exam. So the electron moves here, electron moves here. So this guy now becomes this, and this guy becomes this. And because this guy has lost an electron, it has become positively charged. Sorry, 2 electrons. It has become positive, 2 positive, You lose 1 electron, you become 1 positive. You lose 2 electrons, you become 2 positive. You lose 3 electrons, you become 3 positive. 2 positive. Let's make it closer. And this guy has gained an electron. It becomes 1 negative. And this guy has gained 1 electron. It becomes 1 negative. So the negative attracts the positive. So this is now, you don't really need this again. Whether it is there or not, it doesn't really matter. So this is Mg ion, Mg2 plus ion. This is 1 Cl minus, and this is another Cl minus 2 chloride. So you now have these positive and negative ions coming together, staying together forever and ever. Don't forget, magnesium cannot lose just 1, so it needs to lose 2. So because it needs to lose 2 to have its outer shell complete, so it needs to lose the 2 to cannot lose the 2 to 1 chlorine, because chlorine is only 1, so it needs another chlorine to take the extra 1. Don't forget that. So this is what they become: chloride ion, magnesium. So we have 2. You can see magnesium is a very lucky man. It's marrying 2 wives now at the same time. So it's marrying 2 wives at the same time because it has enough to give the 2 of them. So plus 2Cl minus to give MgCl2 magnesium chloride. So magnesium ion marries to 2 chloride ion to give MgCl2, a happy family forever and ever. Do you understand this? This is ionic bonding, as easy as ABC. One more example, then we call it a day. Now we have seen 1 giving 1. Now we have seen 2 giving 1. Let us now look at 1 giving 2 accepting from 1. Sorry. Let us now look at 2 giving 1. 2 giving 1. We have seen 2 accepting from 1. We are going to look at 2 giving 1 in our next example. We're going to look at 2 giving 1, and that's when we're going to look at something like sodium oxide. Sodium and oxygen. We're going to look at sodium and oxygen. Sodium which is 11, and oxygen, which is 8. Sodium is 11, as you know, 2, 8, 1. Oxygen is 8, and it is 2. The bonding between sodium and oxygen. Sodium, as you remember, has electronic configuration of 281, and oxygen has 26. So oxygen needs 2 more to complete its outermost shell. Sodium needs to lose 1 to complete its outermost shell. Sodium needs to lose 1 to complete its outermost shell. So, as usual, 2, 8, 2. Good. Oh, 1. Sorry. 2, 8, 1, and this one has 2. There's 6 there in the outermost shell. Two, and 2. And it has 2 in the inner shell. It needs 2 to complete this outermost shell to be like a neon, and this one needs to lose 1 to be like neon. Needs to lose 1 to be like neon. So even if one sodium gives its electron to oxygen, then oxygen will still not complete its outermost shell. 1, 2, 3, 4, 5, 6, 7. It will have 7. It needs 1 more. It has only moved 1 step. It has only moved towards chlorine. It has only moved in the direction of chlorine. It needs 1 more. It has only, if it gains 1, it has moved to fluorine. It needs to move to neon. So it's moving gradually. Let's continue. So that means we need 2 electrons. The oxygen needs to gain 2 electrons. Where does it get this? That means we need another sodium. We need another sodium. So we have 2 sodium. 2 sodium losing their electrons to just 1 oxygen. 2 sodium losing their electron to 1 oxygen. Now draw this. So 2 sodium. So the 2 sodium now, after losing the electron now, it will become 2, 8, 2, 8, and the oxygen will also become 2, 8. You can see the electrons flying out to that place. So you can see 2 sodium needs to lose for 1 oxygen to be satisfied. So it is now the other way around, which is forbidden in most places in the world and in most religions in the world. That's 2 husbands married to 1 woman at the same time. Legally, it is not done. So this is what we see here now. So this guy paid oxygen. Oxygen becomes the wife of the sodium. Another sodium paid oxygen. Oxygen becomes the wife of that one. So draw this. Then after drawing this, I'm going to clean it now. The next thing we see is that we have a sodium. Now we have a chlorine like that. So this is the last one you draw. Then we have 1 sodium. We have 2 sodium and 1 chlorine. The sodium becomes, each of them become positively charged, and the chlorine becomes negatively charged. Now we don't need this again. And we don't need this again. So we now have sodium ion as usual, 1 plus, another sodium ion, 1 plus, and this is attracted to them, the chlorine, the oxide ion, 2 minus, because this one gained 2, so go to 2 minus. We now have 2, we have Na plus, Na plus, and this is CO, this is O2. I've been calling it oxygen, chlorine 6, and oxygen. Sorry, I've been calling it chlorine. If I call it that, pardon me. So I have this now. So generally I have 1 sodium gave to chlorine, the other sodium gave to chlorine. The sodium that gave here became sodium ion. This is sodium ion, and this is chloride ion. So we have The overall equation becomes two Na plus 2 of it plus 1O2 minus becomes Na2O. So sodium oxide. This is sodium ion, 2 sodium ion and 2 oxide ion. So oxide ion to give sodium oxide, to give sodium oxide. I believe you understand this. One other thing I want to tell you is this. These ions, they are not just going to stay like this, 2 sodium and 1 like this. No. In a crystal of this substance sodium oxide, in a crystal of sodium oxide, we have millions of these ions there. These millions are arranged in what we call ionic lattice, giant ionic lattice, just in a small grain, in a small crystal. So giant ionic lattice, which we shall talk about in our next topic, in our topic structure. After bonding, we'll be talking about structure. So we'll talk about it when we're talking about structure of substances. So this has been ionic bonding. The next topic is going to be covalent bonding, and I believe you will also enjoy it. If you have any question for me, if you don't understand any part of this video, you know the normal thing to do. You send your email to me and I will respond to you with another email custom made for you. Don't forget that. And it is also good for you to practice questions from the numerous questions in our website. If you don't know where they are, or then you let us know and we'll be able to tell you where to find the questions. So students, good day and God bless.